This is 6th grade 1.2. Lesson 1.2 starts on page 11 of your book. The name of the lesson is whole number estimation. Estimation, most of the time people see estimation and they get excited because estimation means you're not finding the exact number, you're finding the estimated number, a number that's close to it. So estimation for some people is a pretty friendly number. So a pretty friendly word, excuse me. So when you see estimation, you know you don't have to find the exact. So our vocabulary, we have our 2-column notes. So you make your line on one side here, you're writing leading digit. So do that right now, and then you write compatible numbers. Leading digit, an example of a leading digit would be like the number 324. The digit that is all the way to the left in the number would be the leading digit. The one that's worth the most is a way to look at it. So it's the digit farthest, to the left. Sorry about my writing, I'm still getting used to this board, so you're just going to have to deal with that till I do. So let's do one more number. If you had like this following number 2,321, the leading digit would be that 2, which is in the thousandths place. So that's leading digit. Let's see, compatible number. A compatible number, when you estimate, especially we use compatible numbers. Let's put this down here. Compatible numbers. I'll start writing down here. We use compatible numbers mostly in division. We want numbers that are easy to divide. Compatible means they divide into each other easily. They get along really well. For example, a number that's compatible with 12 would be 3, because 3 goes into 12 evenly. Another number compatible with 12 would be 6, because it goes in evenly. Another number compatible would be 4. So you want to try to make numbers, when you're rounding, it's going to say use compatible numbers. That means numbers that are easy to divide. You want to make sure you make life easy on yourself when you are trying to do the estimation, especially with division and multiplication. So let's go on to the first example. Here's example number 1, and I'm still on page 11 in your book. Top of example 1 says, when you round to estimate a sum or a difference, you should round the number to the same place value. So if you look at these examples, and you know, estimating, sometimes there's more than one way to do estimating. Let's look at the example. This is biking. The map shows a biking trail. Biking times for the trail. So you can see the trail right there. So let's see what the next one. Estimate how long it takes to bike from trailhead to the swinging bridge and then to the waterfall. So you're here at the trailhead, which is right over here, and you're going to go up through here to this swinging bridge, and then you're going to go on over here to the waterfall. So we got 28 miles from the trailhead to the swinging bridge, and then 114 miles onto the waterfall. So if we look at the next slide, which is not set up yet, hold on. We go to the next slide. Actually, there's the second question. The biking time from the swinging bridge past the waterfall to the trailhead is 208 minutes. Estimate the number of minutes it takes to bike from the waterfall to the trailhead. So we'll come back to that question. Let's go on to question A. The solution, it says round the 2 times to the same place value, then add. Well, you'll notice that there's 28 plus 114, which is what we looked at in the picture. You'll notice that it says round each number to the nearest 10. That top number 28 doesn't have a hundreds place, so you can't round it to the hundreds. So you're going to round it to the tens place, which in that case would round to 30. And then 114, and since they're saying round to the same place value, since we round that top number 28 to the tens, we should also round the next number to the tens. So we look at that 1. And remember, the rule for rounding is you look at, this is the number we're going to round, this one, you look at the number next to it, and remember the rules. If it's a 5 or greater, it goes up. If it's less than 5, it stays the same, or in other words, rounds down from 114 down to 110. So we got 30 plus 110, which, after you do the calculation on that, the answer comes out to be 140. And in that case, it happens to be 140 miles, or minutes, excuse me, it would take you to travel. Now, estimating, sometimes I would, that's the way the book says. Sometimes I look at 28 and yeah, definitely I would round that to 30. Sometimes I just round all of the numbers to the leading digit. So that one, the leading digit is 10, so I'd round it to 30. This one, the leading digit is 100, so you could even round that to 100. Because remember, you look at the number next to it, the 1, that's not big enough to round it, so that would round down to 100. So that would be 130 minutes, which is also a good estimation. I would take that one if you were doing that problem for me. So let's look at the next one. There's the answer there, writing it out. So on B, if we go back, if you look in your book, I won't go back on the PowerPoint. It says the biking time from the swinging bridge past the waterfall to the trailhead is 208 minutes. Estimate the number of minutes it takes to bike from the waterfall to the trailhead. So you have 208 minutes. It tells you that's how much for the total trip, and we subtract the 114 from the waterfall to the swinging bridge, and you will notice that they round each number. These both have hundreds, so that's pretty easy. We round the 208 to 200. The 114 rounds down to 100, and 200 minus 100 is 100. And I would do, the way I round, I would do that exactly the same way. I wouldn't do it any different. It just happened to work out that both of those have a leading digit, so that one works out really well. Remember, anytime you answer questions that have a story problem, that you always put a correct label on it, and they even answered theirs in a sentence. It takes about 100 minutes to bike from the waterfall to the trailhead. So it's kind of nice to specifically say what you are answering. So let's do the guided practice. You were, just to remind you, you were writing down those examples with me in your notes as you go through. So now in your notes you write guided practice. So here's number 1. It says estimate the sum or the difference. So this is a sum problem because of the addition. That's what sum means. Just a little vocabulary practice there. 27, we're going to round that. And we look at the 2, we look next door to the 7, it's closer to 30, or it rounds up. So we round that one to 30. We rounded to the 10s. This one has a 10. We're going to round it also. 64. 4 is not enough to make it go up, so we round down to 60. 30 plus 60 is 90. So there's estimating a sum. Moving on to the next one. There's the answer. 180 plus 914. So I'm looking, they both have hundreds. So I'm going to round that leading digit. So 180, I look next door, and the 8 is bigger than 5, so it tells me to round that number up. So that's going to be 200. Remember, you round and then all these numbers below it go to 0. The 9, we look next door, not enough to go up, so we round down to 900. And I get 0, 0, and 11. So 1,100. Let's see if they agree with us here. We've got the answers in here. 1,100. Good job. Okay, now we're at difference. We see the subtraction. We see the minus, which tells us that that is difference problem. More vocabulary practice there. So we're looking at rounding 91 and 49. So the 9 and the 1 next to it, oops, sorry, not enough to, so that's going to be 90. 49, the 9 is enough to say, hey, go up. So that 4 is going to go up to a 5. Sorry, my pin's not working again. So that was a 9. No, it doesn't look like a 9, but it is. 9 minus 5 is 4. So we're at 40. And we can see what the book says. It agrees with us. This one has that where it says to round what they did in the example. Let's do this a couple of ways. 612. If we round that to its leading digit, which is 600, the 6 in the hundreds place. The 1 tells us, no, we don't round it, it's just 600. Sorry. And then the 83, we look at the 80 and the 8, and that's 3 is not enough, so that's going to stay at 80. And, yeesh, I don't know how I do that, sorry. This is going to be a 0, and we borrow. That's going to be a 2 and a 5, 520. I might be able to do that mental math. You probably should be able to do that one mental math, dealing with those zeros and just thinking money. You have $600 and you spend 80 of it. How much would you have left? The book, if you remember back in the example, let's do this. They said to round them to the same digits. So the 83, we know we have to round that to 80 because that's the leading digit, the 3. And they said in the book to round this one to the tens place also. So that would be 610 because the 2 is not enough to go up. And then we subtract. Notice, yeesh, I don't know how I do that little thing. That would be 0. That would borrow. That would be a 5. That's 11. Minus 8 is 3. Sorry. And then that would be 5. So I don't know how I do that. That would be 530. And notice over here we got 520. So they're very close. They're very good estimates, no matter whether you want to round them both to the same digit or both of them to the leading digit. It really doesn't matter. Oh, sorry about those lines. I'm trying to get better with this pen. I will. These are the first ones that I've made, so 530. Now example 2, I am on page 12. If you haven't turned your page yet, go ahead. Notice it says using the leading digits. That's our vocabulary word. When you round to estimate a product, you should round the numbers to the place values of their leading digits. The leading digit of a whole number is the first digit at the left, which is what we put in your vocabulary at the beginning. Estimate to tell whether the given answer is reasonable. So example number 2, so when they're written this way, it's kind of confusing. They're pretty close together. That little semicolon right there, which I don't know how I do that, sorry. Let's see if I can erase all this. Okay. That little semicolon right here just tells you that this part right here is the answer. So we're supposed to tell whether that answer is reasonable. So we're going to take this and we're going to round our numbers, and it said to round them to the leading digit. So notice 191 right here, you look at the 9, that tells that 1 to go up, which rounds to 200. 11 rounds to 10, and when we round or multiply 200 times 10, remember the shortcut, just take those non-zero numbers and multiply them. 2 times 1 is 2, and add those zeros, 2,000. So by rounding both numbers to the leading digit, we need to know if that answer is reasonable. And in this case, it's really 2,000 is really close to 2,101, and anyway we kind of rounded up and down a little on some numbers to help compensate for that, so that one's close. Now let's check this one. And you know, I can almost tell by looking at this one that 1,000, just using some reasonableness before we even do any estimating with the rounding on this. Look at it right here, 1,127. Really, that's close to 1,000 if you think about it. And this one's 4. Well, 1,000 times 4. Look at this rounding. We'll see how they do it. I'd round that to 1,000 because that's the leading digit and it's closer to 1,000. And 4 only has one digit, so we don't have to round it. That's kind of nice. And that is, my pen is not working here very well. Again, I blame it on the pen, but I think it's operator error. 4,000. So look at the answer they gave us. 6,508. I don't think that's reasonable at all. It's not close enough. Let's see how they did it. They rounded the 1,000 to us, just like what we did. They rounded it to 1,000 times 4, 4,000. So they say, let's see what they say on it. It's not reasonable because 4,000 isn't close to 6,508. So we got example number 2. This is quotients, It says estimating, we're still estimating products. It says look for compatible numbers when you estimate a quotient, which are numbers that will make the calculations easier. So let's take a look at this example number 3. Environment and standardized test practice usually means it's going to have a multiple choice answer to it. You are in a group of 59 volunteers who are planting 469 trees throughout a city. About, and there's a key word right there, about, which means, about doesn't mean exactly, it means about how many people, so it's an estimate. How many trees will each volunteer plant if you all plant about the same number? So that means we can divide up by the same number. So we look at our numbers right here. We have 469 trees, and we basically are going to split that up with the 59 people who are working. So 469 divided by 59. So here's where those compatible numbers come in. We want to round to numbers that, in other words, I'm going to just say get along with each other. When I mean get along, I mean they divide evenly. So check this out. We got, these are our options, 6, 8, 10, and 12. So let's see what happens as we round these. It says solution, the group of trees is divided among the volunteers, so we use division and to estimate the quotient. So if 59, 469, and 59. 59 is really close to 60. When I'm estimating, I want those numbers to have zeros on the end, is really close to 60. So I know that 60, I'm trying to take a number into 60. I want to know a number that, if you just use the leading digit, 6 won't go into 46. But what's close to 46 that 6 will go into? 6 times 7 is 42, 6 times 8 is 48. So I say let's round that to 420, because that's close to 469. And the reason why I picked 420 is because 6 can go into 42. It is compatible. So 6, if we took the zeros off, 6 goes into 42 7 times, so 60 goes into 427 times. So let's check and see how the book did it. Sometimes, when you're estimating, people can do them differently and still come up with the same answer. So we round the divisor to its leading digit, which was 60, and that's what we did. And they did 480. They rounded up instead of down, and they came up with the answer of 8, and we came up with the answer of, what was it, 7. And let's go back. I don't remember if 7, let's go back here. 7 isn't a possibility. So when I saw that, I probably should have went, uh-oh, that one didn't work, so I should round it up. I know 6 wouldn't work. It would be not enough. So I would have needed to adjust my rounding and rounded it up, since 7 wasn't an option right there. All right. Okay, let's see what we got going here with some guided practice. Okay, estimate the product or the quotient. So remember that product is the word that means to multiply. Quotient means divide. Product, multiply. Quotient, divide. More vocabulary. So we're rounding 879. We round to that leading digit, the 8. We look at the 7. It's big enough to go up. So that's going to be 900. 31, that's easy to round, rounds to 30. And the nice thing about multiplying is you multiply the non-zero numbers. 9 times 3 is 27, and add 3 zeros. So 879 times 31, the product, the estimated product, is 27,000. So we have another product problem right here, 193 times 4. So we go 193. We look at that 1. We're rounding that leading digit. The 9 tells it to go up. That's 200 times 4. 2 times 4 is 8. Add 2 zeros. We got 800. That works out great. Now, usually on a computer, this little slash means to divide. It's like written as a fraction. If it was a fraction, it would look like this. And really, technically, fractions mean to divide. So we have 970 divided by 4. So we have 970, supposed to be 7, divided by 4. Now the nice thing here, the 4 is already rounded. We don't do anything with 4. We leave it as 4. But we need to change this to a number that's compatible with 4. What can 4 go into that's close to 900? Well, really there's 2. You can go below. Below 900 would be 800. 4 can go into 800 easily. If we go higher than 9, 4 can't go into 10 evenly, it could go into 1200 evenly. But I think it's closer to 800, so I think we should round this to 800 and take 4 into 8, which goes 2 times, and then add your zeros. So it would be 200 approximately. So let's see if the book maybe did it a little differently. If they did, we'll talk about it. They did 250. Oh, I know what they did. They probably rounded it to, look what 4 can go into 1,000 if you look at that. Because 4, if I crossed off this 0, 4 quarters make $1. Think of 100 as $1. I think of it as 100 pennies, and that would be 25. So that also works. So you can see there's lots of ways to estimate and still come up with answers that are really close. So we have another division problem right here, looking for the quotient. 213 divided by 68. Well, I'm going to take that divisor, the 68, and I'm going to make that be a 70. Round it to 70. And what's really nice is 21. 7 can already go into 21. So I'm going to leave that and put a 0 on the end of that. So now you just take 7 into 21 goes 3 times, and that 0. You took the zeros off, you could see where the 3 comes from. And that one was pretty obvious. So the answer is 3.